Hello, and welcome to my show. My name is Bret. This is my YouTube / Twitch / Periscope live stream every week. Started streaming on all three of them, so you choose where you want to watch. And I've been doing this for a while. We're coming up actually on the 2-year anniversary of me streaming nearly every Thursday about container stuff. So set your watch, synchronize now. This is when you should show up every week. And we're talking about Docker and DevOps, everything automation and DevOps in the world of containers. So any container tool is a topic. We've had plenty of guests on this show talking about all sorts of tools. And today I have, again, another No Agenda Thursday. So this is all about your questions, what you want to do. We can dive into things. Last week we dove into a backup tool that I built called Docker Backup with a V. And I'll just show a link of that in a few minutes. But before we get started, if you're on YouTube or if you're on Twitch, do that whole subscriber thing. If you're on YouTube and you subscribe and click the little button, the little dinner bell button, you basically get a notification on your phone when I go live. So you don't have to sit around in the waiting room. You basically will know right away when I'm on the internet. And of course, in the links below on YouTube, there's links to my website, all my free stuff, my courses that you can buy, which are almost always on sale, and all that good stuff. So enjoy. So let's talk about containers. You've got questions. I hopefully have some answers, and if not, maybe we can figure it out together. So I hopefully fixed my audio also as well from last week. Last week I had a really weird audio issue where things were clipping, and I had a right channel only kind of situation where the left channel was cutting out. I tested, and hopefully that's all gone. So you let me know. Let's see what we got in chat. So before the live stream started, we had some early risers jumping in and asking some questions. I have a request to deploying stacks on Docker Swarm, on-prem Docker Swarm storage for production, learning to deploy Airflow on Docker Swarm cluster as part of my practice. Any content related to CI/CD of deploying Airflow. So I don't know Airflow. Maybe I do, but I don't recognize the name. Is that a testing tool? I don't even know. So I'm going to focus on the tooling for any app. Like usually, whatever the app is you're running in container, it doesn't usually change how containers work, how you use containers. So we can get into CI/CD if we want to. We can focus on a specific image, PHP or Java. All right, so test. Give me some examples of exactly what you want to know, because I could fill an entire day, and I often do in my consulting, of just talking about Java in containers and PHP in containers. I even have some examples of those two things. So if you want... Are you talking about Docker files? Are you talking specifically about, multi-stage? Like, what exactly is it in those that you're most interested in, so that we don't consume a whole hour with one programming language? That way we can all learn something, just in case not everyone's on Java or PHP. Let's see. Keen on anything you can say about volumes and sharing them across Swarm nodes for the use on generated content. I'm looking at Amazon EFS at the moment to solve this. Pam. I'm not going to be able to help you with Pam. In general, I never deal with it. In fact, I don't think I've had a single consulting client ever deal with it. So I'm not going to have a good advice on that. Can I use Docker Swarm for production? Absolutely. People have been doing it for years. Over 700 companies have used it and paid Docker to use Swarm in production for years. So yes, it is a perfectly fine production tool. Is expose and Dockerfile redundant if I do ports in compose? No, think of expose as doing several things. The expose command in a Dockerfile is... one, it's documentation. So a Docker file in and of itself is not just a build command line list, right, of all the things that have to be done in order to build your app properly, but it's also the single source of documentation for what your app needs. So it's all the environment variables. It's the ports that it needs. It's the command that's supposed to run when the application starts. If you think about it, a lot of languages don't have a consistent way of doing that. Every language has their own package file, their own descripting language, and a lot of them won't even tell you the exact command that's supposed to run the application. So in a Docker file, treat it like your documentation. Put tons of comments in. Every single line should probably have some comments about why does that exist. Whenever I'm on a project with a client that is about Docker files, and we usually start with Docker files, it always starts with describing the things that are going on that Docker file. Why do you need all 20 of these apt-get dependencies? What is each one used for exactly? Because so many companies just throw everything in. Do you really need curl installed in your production application image? A lot of companies do stuff like that. They put Git in there and curl and other unnecessary tooling. So I always want more documentation. And expose is kind of like documentation. It's telling you all the ports that the application expects to have coming in. Kubernetes does not use the expose stanza. So inside the Dockerfile standard, the Kubernetes will not use it to publish ports inside of a service. So it's only going to be for Docker if you use the -P. That's when the expose command is technically used. So if you're doing stuff in Compose, I would still have it as part of the documentation in the Docker file. And in case someone wanted to run your app with just a Docker run, they could use the -P, and it would make sure that all the, when I say that, I mean the P, not the lowercase p, but the capital P, will make sure that all the ports that are listed in the expose are properly exposed on random high ports. And a lot of people still do that, especially for local testing, so that you don't have conflicts. All right? So I would absolutely use the expose command. CKA. Well, I don't have a CKA, so I'm not going to be very valuable, Abdul, in recommending CKA. There's lots of resources out there. And over time, my Kubernetes mastery course is going to be built. One of my goals is that it gets you farther into the CKA test requirements. Right now, that is not the case. The Kubernetes mastery is more focused about getting you the functionality and getting into it. And like we're building the storage sections, and I did the ingress. But CKA is very much heavy onto the command line options, so I'm told. So I think once you've learned the basics of Kubernetes and you've actually used it a few times, I would go focus on really memorizing a lot of the command line options. That's what I hear is a big deal on that test. Docker context. So how to configure different context. So there's tons of episodes. We've talked about context for over a year on this channel. I can give you a quick demo. Let's see. On context, but it's just the Docker context command. So if you just hit Docker context, then you will see all the subcommands of that, and it's you just add them that way. But I can give you a demo. Let's see what else we got. Airflow is a ETL job scheduler. Okay, I never have used Airflow. So to me, a container is just a container. The only thing I have to worry about is what does it need to talk to, what ports need to be open, and what environment variables does it need, and how much resources do I need to reserve for it. That's really, in terms of the DevOps person who's not necessarily managing the applications. And now maybe you're going to be an Airflow person. You're actually going to use that to do some job stuff with it, but that's probably more of I'm going to guess, a developer tool. Dockerfile, Java Spring. CKA preparation tips. Well, I haven't taken the CKA, so I can't help you with that. Deploying database on Swarm as master and slave. All right, so yeah, databases in Swarm is a thing, and each one will be different. So I'd say your first Swarm should not have databases in it. If you can avoid, as long as you can avoid it, don't put databases in containers. It's so much harder than letting someone else manage your databases. So if you're in the cloud, I'd say let them do it. But yeah, you can set it up manually. You can set up your master and then set up the replication, right? In a database, you can do all that manually. And then with Swarm, I would look up that database plus autopilot. So the keyword with Swarm for a while was looking up autopilot patterns for database replication, and you might find some scripts and stuff like that. But we don't have operators in Swarm like we have in Kubernetes, so you're not going to see a lot of advanced deployment solutions necessarily for databases. But it depends on the database. So tell me the database, and maybe I'll have some recommendations. What do you think about private enterprise platforms that use Vagrant as mandatory development environments? That's fine. Vagrant's kind of the old school way of doing things before the container world came around about 5-6 years ago, when we started to see the tools like Docker Machine and Docker Compose and Docker Desktop. Those things all started showing up. Now we have things like Minikube and Micro K8s and all sorts of Kubernetes local installation options. If you're using Vagrant, it's fine. You can run Docker in Vagrant all day long. It's just a lot of work, and it's a lot to maintain comparatively, because you usually have to run your Docker files and your Docker Compose files on top of managing your Vagrant configs, which is a whole separate thing. So I usually, when I'm working with companies, I will remove Vagrant from the pipeline, and we will replace that with something like Docker Desktop. And they just won't need Vagrant anymore. So it saves them the time and effort of those scripts, the Vagrant config files, and it saves them all those downloads of those big VMs that they didn't have to, they don't need anymore, right? So they could get rid of the big VMs and save space. Let's see. Do I have to pay in order to use Docker Swarm in production? No, Docker Swarm, just like Docker, is fully open source. In fact, the Docker company doesn't even have any closed sourced products in terms of your desktop tools. So they sold all those to Mirantis, Docker Enterprise, and stuff like that. So no, Swarm is free. Some advanced features of Swarm are paid. I am not aware that is the case. I do not know of any specific Swarm features that you pay for. Docker Enterprise adds custom Docker tooling like Docker DTR, which is a registry, and Docker UCP, which is a web interface, on top of Docker and Swarm. But those to me aren't Swarm. Those are just extra features on top of it. So Swarm comes from the SwarmKit repo, and that is fully open source. So if you want to see all the source code and all the functionality of Swarm, you can even run Swarm without Docker if you really want to. Just look up SwarmKit. It's on GitHub. And SwarmKit is basically a library that's plugged into Docker when they build Docker, and that adds the functionality for Swarm into the Docker engine. So yeah, Swarm is open source. Local development best practices for Docker, using Swarm and experiencing slowness when bind mounts, for example. I never use Swarm for development. I don't ever use Kubernetes for development. I've had many people on this podcast or show, or what do you want to call this, that are not necessarily thinking that you building local orchestration simply for development, that a lot of us don't think that's the right pattern. We think that you should keep it simpler, and that if you don't need to spin up orchestration simply for development. Now, if you're trying to do testing like manifest YAML or Swarm stack YAML, stuff like that, that's not really development. That's testing your DevOps, right? So yes, that makes sense for building out orchestration locally. But for development, ideally, you don't need 20 different containers running for development. If you are, I will quote Kelsey Hightower, who had on this podcast last year, and Kelsey said, if you need that level of advanced local development environment, you're building a distributed monolith. I think is what he said, which is a great quote. Ideally, if you're building locally, you don't need to spin up more than 5 to 10 different applications, even if it's microservices, in order to do some testing and development. And that's what Docker Compose is exactly designed for. So every team that I've ever worked with for 4+ years now, we settled on Docker Compose as the way to set up their development environment. Regardless of what their production was, whether it may not even have used containers. It may have been Docker, it may have been Swarm, it may have been Kubernetes, it may have been ECS. It did not matter. Eventually, we figured out that the major benefits that you need and the major automation you need for local development, those problems were largely solved by Docker Compose, where everything else was either too resource intensive, too complex, and really just got in the way of the developer. So anyway, you can tell I'm a big fan of Compose. So obviously there are people that are doing lots of stuff on Kubernetes, but I don't ever do on Swarm, so I don't Not swarm, I meant compose. Okay. Sorry, I was going on and on about a rant that you corrected yourself. All right, so I'm going to get into some of these questions since we've kind of dove into some of this stuff. So let's pull up the green screen and get dirty at the command line. Oh, and I'm going to turn on some music this week so I can have, while we're actually coding away, it'll be a little bit more Twitch style today with some music and some command line, and we're just going to get into it. Pull up the magic green screen. All right, so let's make a list. Let's make a little list of things. Let's see. Talked about compose, dev, tips, swarm. We'll do swarm first, but swarm volumes basically is what we're really talking about there. Swarm volumes. Java and PHP and Java containers. And let's just do that. Make that a little bigger. Put that up there at the top. Let's actually put it over here. It's a little bit out of the way. Okay. Do these live streams go up? Yes, as soon as the live streams are over, especially on YouTube, they just stay around on YouTube. So if you go to my YouTube channel, Bret.live, that's that little URL at the top up there. Burp, burp, right there. Yep. And you go there and all the back streams are there. Recommended tool for monitoring Docker containers like Datadog. Yeah, Datadog's fine. Every monitoring tool nowadays supports containers, so every single person I talk to has their own tools that they like and they've used. So you've got do-it-yourself tools like Prometheus. You've got SaaS products like Datadog. I've had lots of experience with Datadog, and I'm a fan of them, but they're also not cheap and they're not simple, right? So they're designed for large setups. So if you only got 10 servers, you may not need the full, Datadog scope. But now Datadog is even nicer because they have logging built in, plus the monitoring and metrics, so you can kind of have a one-stop shop. So I like that. I like being able to do that. It wasn't very long ago that you had to have a separate logging tool than your monitoring tool. Earlier this year, we had LogZ, LOGZ.io on the show, and they have a solution for monitoring. They basically use ELK for logging, and they're starting to add metrics in there as well. So it's starting to become one solution that uses open source tools that you don't have to manage. And I always prefer to use someone else's tool when it comes to logging and monitoring. I don't want to run my own infrastructure if I can help it, because we're all way too busy. We've got way too much other stuff to do. And if I can outsource logging and monitoring, I always do it. All right. All right, let's see what we got here. By the way, I was just upgrading my Multipass. So you've heard me probably talk about Multipass here a couple times in the show. Multipass is basically it's tiny little VMs that run Ubuntu. So if you check out Multipass Run, it's basically the easiest way, I think, to have a generic full Linux server on your local machine. So it's not for running cloud instances, but as Docker has sunsetted Docker Machine, so we no longer, it still works, but Docker Machine was really a way to make tiny VMs for running Docker. I have replaced that with Multipass for my local setup. So I now do Multipass list, and you can see that I have basically every version of Kubernetes, and I'm gonna make this a little smaller. Make this do that. And so yeah, so check out Multipass. If you're trying to set up multi-server stuff locally, Multipass will spin up a VM, and then you can install whatever you want in it. You can install Docker. It's unlike Docker Machine, it won't install Docker for you, but you probably need to get to the practice of just how to install that, and you need to get good at that anyway, right? So so Multipass, here's the URL for Multipass if you want to go check that out. For the last question on ZSH shell, yes, bretfisher.com/shell. I don't have necessarily a video, but if you look at my YouTube channel, which is at bret.live, if you go there, if you go back maybe 3 weeks, there is a live 3 or 4 weeks ago, there was a live show where I did nothing but talk about my shell. So the Docker in the shell, I'm not sure what you mean exactly. If you mean the logo, I can just show you. There's a basically I have a theme, and I share some of those on that shell website, Docker files theme dot files. My ZSH custom themes. I think it's this one. So it's a pretty, I basically stole everyone else's, and I do a Docker context show, which is a beta feature. So if you just talk about the logo, then you just go to my website, and you go to /shell. And then scroll down that list, and it gets under custom ZSH prompt. So right there gives you, that's what you want. Look for that theme, put that in there, and that will give you basically the whale emoji. Right. So on our list was swarm volumes, because last week you were on and you were asking about swarm volumes. So yeah, let's do that. We're right there. Okay. So the first question you ask about was swarm volumes. First question is, what is the storage you want to use, and what are the requirements of your application? So the conversation is not, let me go research all of the tools for Swarm. That is not the first step. The first step is you need to understand what application requirements you have. And so someone mentioned EFS. So EFS is Amazon's built-in NFS solution, right? It's a server on the network that it provides NFS shared volume support to multiple nodes. And so really the job of the orchestrator is to connect a particular container to a particular mount on Linux, right? So that mount might be local disk, it might be remote disk. It just depends on where you want your data stored. And so all of those problems before you get into the Kubernetes CSI driver or the Swarm Docker driver that helps with that, you need to know what your application really needs and where that storage is going to be, what type of storage, does that storage perform the way you need it, and none of that has anything to do with containers. That is all about applications and their requirements and performance of storage based on your application, right? Because a MySQL container on a server that happens to run Swarm has the same requirements as one that's not running in a container or running in Swarm, right? The one added thing that orchestration can add, it doesn't have to, but it can add, is if your requirements are that if that node goes down, the application spins up in a container on another node, and that the volume or the data is reconnected on that other node. That can add a level of complexity to your storage setup. That is the job of an orchestrator or an orchestrator storage driver, more precisely. And so to me, that's the last piece of the puzzle, not the first piece. The first piece is to figure out the storage you have available. Are you in a data center? Do you have VMware storage? Are you using their solutions? Are you using NetApp or advanced iSCSI solutions or NAS or SAN or there's all this stuff out there, right? If you're on a cloud, you're beholden to their cloud storage usually. So with AWS, you have the built-in EC2 storage, you have the EFS storage, which is the shared solution. All these decisions have to be made before you can start looking at, does my container solution help with that, or does it have a driver that uses that? So with EFS, let me see if I can find Docker. So here's an example. DC 2019. Let's go. All right. Okay, so Brendan Mitchell, if you haven't met him, he's been on this show before. He's one of the Docker captains, and he has an excellent presentation on Docker tips from the captains kind of thing. Registry mirroring caching. Yeah, I'm going to tell him his URL is down. Yeah, and that was down too. All right, let's see if we can get the PDF. All right. So what I want to show you, and I have to scroll through this. Can I search it? Let me download this PDF and I'll show you what I'm talking about. All right, so Brandon has a really good presentation on a bunch of tips. And I'm going to put this URL into chat. And I'm going to open this. And let's see. All right, how do I go to the next page? What I want to show you is the Docker built-in volume driver can do more than you maybe think it can do. So he's got networking, troubleshooting, all sorts of tips. It's really a great presentation, and you should just go look up his tips and tricks talks at DockerCon 19. And he's using BuildKit. He's got advanced tips on pruning and cleaning up. All right. So the local volume driver is the one driver that comes out of the box with Docker. And it can do more than just talk to your local machine through a bind mount or through a Docker volume that's controlled by Docker. So for example, you can mount NFS, which is what EFS uses. So if you start Googling around for Docker EFS, because the thing about Swarm is that Swarm is an extension of Docker. So chances are you might be able to use it with the things that are just Docker related. So you may not have to always search Swarm. There's some cases where Swarm is necessary, and we can talk about that. Swarm support, rather, is necessary. But here you can see that you're throwing in driver options. See that driver -- OPT? So you can do more with the local built-in NFS than maybe you realized. This is also in the Docker documentation. You can actually go to docs.docker.com and find this stuff, but it's a little bit hidden. So it's not super easy. You might have to search for like Docker volume NFS in the documentation, and then you'll find examples like this. And then this is showing it in Compose, which is for Swarm, right? And you see he's creating the volume first, and then he's mounting it in a service, just like you normally do. You can even specify external things. Basically, you can mount locations instead of just using a bind mount. You can actually mount locations in the file system that aren't directly under, var lib Docker, which is where Docker volumes are normally kept. This is showing an exception to that, where you can mount it somewhere else to a dedicated device. That's another example. Actually using overlay. So you can use different types of volume mounts. So this is actually an advanced named volume. So it allows you to use the named volume support, but also bind mount it to a different location. So yeah, so go check those out. Try, it's a funny one. That's nice. Yeah, and he's actually showing, by the way, that you can even mount now volumes inside of Docker files in case you need to bring in special stuff that requires something outside of your current working directory whenever you're building. So I'd say spend some time troubleshooting, digesting that, like testing those things, because you may find that things like EFS don't need a third driver, a third-party driver. You just do it right out of the box. All right, that's sort of the opinion there. All right, so storage. Storage is maybe another one. Right? And it's a storage solution. I have not used it in Swarm, so I'm not going to have an immediate opinion on that. But we should try some of these things, right? We should try some of these third-party things. Another one is Portworx. Portworx supports Docker and Swarm. It's a paid enterprise volume management solution. Let's see, what else has anyone tried? Anyone else tried something different? There are drivers, for example, for Docker volumes for things like NetApp and other dedicated storage. Some of those dedicated storage companies have their own drivers for Docker. So if you're using data center storage, it's all about talking to your storage vendor and finding out what that storage vendor supports. Now, when it comes in terms of your applications, for those of you that are rather new to Docker volumes, remember that volumes don't solve the fundamental problem of your application's data requirements. For example, if you're using MySQL, you don't want file replication technology. That's not the answer to a MySQL database, right? A MySQL database typically uses some sort of built-in replication at the application layer. It has, same with MongoDB, other things like that. And so they're very specific to that application. And you typically, when you're starting out, you typically, the simple way is to use local volumes and pin each one of those replicas to a particular node inside your orchestrator. I think a lot of things that get people in trouble really quick is they want this magic unicorn solution of, I just want my containers to spin up everywhere. I want them to all have sort of what we call what is it, zero. It's only using local storage, so that means it's replicating through the storage engine. It's not using a shared storage like an iSCSI or Fiber Channel or NFS or anything like that. It's not using a external shared storage. It's using something in the machine, and they want it just to all work magically. Well, that's really advanced, and I know teams that have tried to use something like Ceph, right? They're really good at Ceph. They were using Ceph before containers, and now they want Ceph to run inside containers on any node, anywhere, and just magically replicate and spin up wherever it wants and replicate to wherever it's going to go. And that is a lot of work, and it's hard to do. So I had a conversation last year with a team that was saying, how do we do this? And I said, well, why don't you just not put them in containers? Like, if you know how to do Ceph and it runs great on your dedicated host just for storage replication, just do that. Like, if you're having problems with containers because the containers are moving around, either pin the containers to particular nodes and make sure you have, your replication enough that any one node that goes down or any two nodes that go down, you still have your replicated storage. But the reality is your managers, right, in Swarm, they don't automatically move around and replicate. So you have special nodes for those. Consider having special nodes for your storage. This is all an evolution. And so many people come into this wanting the utopia solution right out of the box on their first cluster. And I work with teams all the time that they tend to end up not doing that because they have to scale back their desires because they haven't yet learned all the stacks and the levels of things that they need to change in order for everything to work perfectly. And storage is still a complicated problem. Orchestration has not made storage easy. It makes it a little bit easier to manage, but when you start talking about flat file replication and database replication, those are two different things, and they have two different solutions on a lot of cases. So I don't have a magic button that suddenly is free, easy, and completely reliable for all those storage requirements that everybody has, right? Let's see. Yeah, so test. At this point, we're not recommending. I'm not recommending you use Rexray because unless it's been maintained recently, it's kind of a dead project. Let's look at that. GitHub, Rexray. See if so. EFS. So for example, if you look at Rexray, the project at the last commit was 1.5 years ago, and a number of issues are cropping up. I still find that it works on DigitalOcean, but I would never recommend it to a customer because the open source project basically died. The company, it was run by Dell, then VMware, and basically the team got split apart and the companies didn't want to support it anymore. So I think they all basically jumped on the Kubernetes bandwagon, and Rexray was focused really on Swarm. And, so I know people that have had issues in the last year on Rexray and they're not getting fixed. So they've kind of moved away from it. But if that works for you and you're willing to do that for small, personal projects, stuff like that, why not? I mean, we have lots of code that's old. Maybe some of it's even not maintained, but we're still using it. I just want to give you that warning. I have not tried, by the way, using EFS recently with Swarm without for automatic failover. So again, with all these things, with EFS, you want to make sure that you're mounting on multiple nodes, and that what are you trying to do with that storage, right? Is it simply mostly just read-only on EFS, and you maybe occasionally write files to it? So maybe you have like multiple servers running WordPress, and you need all the uploads, all the content of WordPress to be on a centralized storage. So that probably will work, but you don't want to look at something like databases over EFS, because you don't really need your databases stored on EFS. You need your databases to be on really fast local disk, and then you need database replication at the database layer, which doesn't require multi-node read-write. And that's where it gets into the whole storage solution situation, where, for example, if you look at DigitalOcean, DigitalOcean has DigitalOcean block storage, but it can only connect to one node at a time, and it cannot be multi-node read-write, which is a feature of storage. Specific storages have that, most storages don't. So that has nothing to do with containers. And so a lot of people think that containers can magically just run on multiple nodes and write all to the same location. That's often not the case. You usually need something like EFS to do that. Some specialized iSCSI solutions can do that, but I don't know that you can do that in any iSCSI stuff in the cloud or whatever. So again, that has nothing to do with containers, actually. That's more about your storage system. So you have to learn the storage world, basically. You have to learn what storage does what storages support what. There's all pros and cons to every storage. There is no magic solution that is cheap, really, really fast, supports multi-read-write all at the same time to multiple nodes. So Toaster Chicken, fantastic name. I dumped a bunch of ideas for new small cluster storage and just ended up with the local driver. I was talking to my storage guys about getting access to their Cephs, but was meh in the end. Yeah, so that's the thing, is you have to really know containers really well. Then you have to understand orchestration really well, and how your applications behave, and when they're spun down and when they're spun up on another node, how do they behave? And then learning about replication at the storage level. So Ceph or other replication solutions, Gluster, all these solutions have their own way of replicating, and putting those in containers or having some special container driver for that doesn't necessarily solve the problems of the replication. And like I was saying, last year that team actually chose to just keep Ceph separate, and they still use it in containers, but they maintain it outside of the cluster. They basically go into each node and they set up the replication at the nodes, and then for the containers know where the storage is on the local machine. They do bind mounts to that local storage, and Ceph runs on the host under systemd and replicates the proper things. And then the containers are constrained so that they only run on the nodes that have the storage that they need, right? So they're using Ceph, and then I know a number of teams that are using Ceph successfully, but they're not necessarily running it as a special driver and running Ceph in containers themselves, right? Because I don't know how well Ceph does when suddenly one of your Ceph nodes moves to a different node. Because does this storage move with it when Ceph spins up on a new node? Probably not. So it can be really tricky there. It's kind of a chicken or egg situation with that. So. How does Ceph replicate across multi-region or hybrid use cases? I don't know, because I'm not a Ceph person. I've demoed it a couple times, set it up, but I am not the storage expert. So I'm not, my advice for teams usually is I tend to be very conservative on storage. Storage is the most important thing of your entire solution. Nothing will cause you to lose your job faster than losing all the data or corrupting all the data. So I tend to be very conservative on using paid storage products. And that means cloud storage that they provide, dedicated cloud storage, dedicated, RDS for databases. I don't want to run my own storage, essentially. And when I do, I usually get a true vendor solution. I don't try to throw together a bunch of my own open source stuff to do it. I'm very conservative in that way because as a consultant, I'm not with a company very long, right? Like I don't work at a company for 5 years. So if I come in, I deploy some fancy Ceph solution or a Gluster or something else, and then it goes haywire 6 months later and they don't have anybody that knows how to run it, they're going to be in a lot of trouble. So I don't want to give them something that they don't know how to run themselves. So I tend to advise them to go buy something. And a lot of those companies buy their own data center enterprise solution, right? From HP or Dell or, NetApp or storage. Some of these consolidated vendors, right? The ones that provide you the all-in-one solutions, the hyper-converged storage, plus CPU and compute and networking and all that, right? So I would say that every project I'm on, they're using a different storage provider. So I don't necessarily become an expert in any one of them. Yeah, local drivers. So yeah, local drivers could do a lot more. If you start diving into the documentation, like I said, go look at that scrolling up and looking at the presentation. But one of the things that I do want to do, and I don't know when we're going to be able to do this, but coming up with some of these solutions, basically a list of currently working solutions for Swarm storage. And I think I need your help for that. And coming up with whether it's a Git repo, some sort of README, maybe it's a blog post or just a gist or something that are validated solutions for using Swarm with storage. And that might be storage on every node that's replicated using something like Ceph. It might be using EFS if you're in AWS. I personally still use, I still have a Swarm that runs on DigitalOcean, and it uses the RexRay DigitalOcean driver. That driver still works, and it moves the storage from one node to the other whenever the container stops, right? And if the container moves, the storage moves with it. So I would consider that in that specific use case of a single node talking to, so it's single node write, and it doesn't even have multi-node read. It's just single node connection to the DigitalOcean storage using a Swarm aware driver. That works for me in DigitalOcean on a multi-node setup. So I'd like to come up with a list of like what works in 2020, because now that RexRay has started to, as it's gotten older and the bug list has increased, people are looking at other solutions. Portworx is still saying that they have a viable solution, but it's only free for 3 nodes. If you want a larger solution, it's a paid product. We have lots of other things like Gluster out there, and I don't know, I haven't tested a valid solution with Swarm and where that works and where it doesn't. Where are the edge cases? What applications are good for this kind of product, right? The same thing goes for replication with databases. A lot of people want to set up replication in Swarm, and now that you have everyone's focused on Kubernetes, and on Kubernetes you have operators, and so these operators with their CRDs are allowing people to automate database setup, but we don't have that in Swarm. So if you look under autopilot, let's just look up MySQL. Right? You might find an autopilot pattern, MySQL, and it's really just some shell scripts that automate the setup of MySQL, for example. But this is super old. This is over 2 years old, right? This is 2.5 years old. So probably not well maintained. I don't know if there is a fork that's being maintained anymore, but I would love to come up with people have validated that this works for them, and they've tested failover, they've tested recovery, and what works today in 2020. So maybe we'll do that. But that's going to take work, right? And if it's just me doing it, that's a lot. That's many hours of effort to validate all those configurations across multi-cloud. So maybe we need to come up with we need to come up with this little so like EFS on AWS for shared read write. Right, so that's a specific solution, and built-in volume driver, like who can validate that and do some failover of, you know, something like a WordPress site or a Go site or something like that, and we have that, and we can say, yep, it all works as expected. I can say DigitalOcean block storage, single node, read write, X-ray works. So something like that, right? I'm working on my markdown here. Yeah. Yeah, I do feel like the database stuff is technically separate, because most databases you don't want on EFS just because of performance, and most databases they have their own built-in replication mechanism. So it's more about making sure that they can find each other and that they can re-replicate to their local storage. So it might, you know, when you're first starting out with databases, I would pin those databases to specific nodes and use local storage to keep it simple without having to worry about storage drivers and all that stuff built in. So if you're doing a MySQL mirror, you just know that there's two special nodes that you maybe label those nodes with MySQL or whatever, and that you replicate those across those two nodes, kind of like you would do with managers, right? Your swarm managers are dedicated. They don't necessarily hop around, so they are special nodes. You might even have your own AWS auto-scaling group just for those, and because you're gonna need more storage on those database servers, something like that. There we go. And it works as intended. So Dave is validating that. So we need examples too, right? So my example, by the way, that works on the Rexray. So if you go over to dog versus cat, my example here, it uses DigitalOcean's, I think, for the examples. So if you look here, I have a stack Rexray, and this is not specific necessarily to Rexray. This is just the question of, if you're going to install a third-party driver into Docker for storage, how do you do that in a swarm? And here is a example of me creating a service that all it does is it runs something called the swarm exec, which is basically just an image that has Docker installed so that I can run a Docker command from inside a container. And then I mount the socket to the host so that I can control Docker on the host from inside the container. And then I run a command in there once. Notice how I had the restart policy condition none. So I do, okay, yeah, it's Rexray Dobbs, right? So in fact, I might just do this whole thing as my example URL there. And that gets the job done. Sometimes it will end up rerunning. I use secrets to store the token. So I use a Docker secret like that. And Rexray essentially at that point will create storage for me on DigitalOcean as I spin up containers that need it, right? So the way that looks for each application. Let's see. If I do, I don't want EE. Stack ghost. All right, so here, so you see on my database how I just have the regular volume mount for the database. This is MySQL. It's just a regular volume mount to a named volume called DB. And then here under there, you're specifying the driver. So if you don't specify a driver in Swarm, it will always use the default built-in driver, right? So I'm specifying this driver, which has to be pre-installed on each node. So step 1 is you have to deploy the stack to install it, install the driver. Step 2 is you deploy the stack that uses the driver. And so I'm saying I only need a gig in size. That size is in gigabits. And these are all custom driver options. Each driver would have their own. But again, I still use the RexRay mostly because that swarm has been there for years and it's been stable, so I haven't been messing with it other than just updating every month. I do security updates and Docker updates, but the driver itself has worked. I don't think that is the case of all RexRay drivers over AWS and Azure. Some of those are having issues. And I know that some people have come to me and said that this driver in particular for their solution doesn't always work right on DigitalOcean either. So that's the kind of the problem with a open source repo that's dying over time, is that the issues aren't getting looked at. Nobody's implementing fixes. So yeah, so RexRay, so the autopilot pattern, maybe we need to make a list, like a tools list. And we know that Lustre is a potential tool. Ceph is a potential tool. I'm just going to put RexRay in here for now, just because, even though there should be a big caveat there. Storage. I think I had a blog post. See if I can find that blog post. Yeah, here we go. So here's this is a year-old post that I found on the workaround.com. I don't know whose blog that is, but they go into some pretty good descriptions, and then they list some of the things that they found. Convoy, which I have not tried. Did we put Portworx in that list? No, we did not put Portworx in that list yet. And we've got Ceph. We did RexRay. Gluster. Storage OS. So I don't know if Storage OS does have a Docker support one. Let's see if that's. Yeah. So Storage OS goes on the list. And I've never used that one either, but it seems like there's some stuff there. And yeah, Longhorn. Although I don't know that. So Longhorn might be a solution that works. It's one of those things where it's probably not going to be a Docker driver. So we're talking about Rancher's storage solution. And they continue to work on it. But if anybody has ever tried it, I have not. I've been keeping up with at least reading about their progress and the versions, but we could put that on that list and see what happens. Like everyone else, everyone's focused on Kubernetes. So, to get it working in Docker or Swarm might require more effort, or possibly running it outside, like natively on the host, which again, for storage, not out of the realm of, possibility, just because storage is still hard. And I really, really don't want to run my own storage. So if I can outsource it to cloud storage, I always do. But I understand that all of us, locally on our machine can't do that. And I'm going to actually put Brandon Mitchell's tool on the list. I'm just going to call it the built-in. Built-in example. And yeah, we'll see how far we get on that. All right, so I think I threw that blog up there, didn't I? No, I'm not sure if I did. All right, so this workaround blog, they go through Gluster FS. And I'm thinking they installed it on the host, right? Because you see a lot of system control. They're basically dedicating nodes to replication. I don't know about this Extreme FS one. Let's just, I'm gonna Google. Let's see. It's all supported version on a Docker host. And I have heard, I can't remember if I heard if someone was using Longhorn in production. Yeah, so look at this. This was a month ago. This is probably what the last thing I saw was. It reaches GA. Right? So, Toaster. If they've claimed it's GA, what is it missing? Do you have some experiences? Toaster Chicken? Do you have some experiences that you think it needs something in addition? I want to see if there's any talk of Swarm. There we go. There's an issue for Swarm support. Yeah, so that was... It's a super short... Let's go into... Oh, that's just them trying to get it working. Yeah, I mean, in theory, anything that doesn't work in the container, if it's just replicating storage or connecting storage at the host level, all container solutions do that. They support that because they will just bind mount into the storage, assuming that those containers are locked into the nodes that have the storage available. That is all... doing that stuff outside of the container engine or Kubernetes or whatever, that all still works. When you start to get into Kubernetes specific, what you're really talking about is dynamic connections or dynamic replication of stuff from one node to another when containers move around, and that you want it to be sort of a self-healing automated solution, and you're using the container orchestrator to do that. So that's when we start to get that advanced, that's when you do need container orchestrator support. But almost all of these standard Linux replication file solutions would all work in Docker or Swarm if you're willing to dedicate specific nodes and set the things up on the host, all that stuff, right? All right, so if anyone's, we're going to come back to that if we have a chance. I'm already been on here for an hour, but the other thing that was asked for was compose dev tips, PHP and Java containers. So let me just show you a couple of things I already have on those real quick, and then we can come back to storage. So under my GitHub repo, I have, if you just search PHP, I have a pretty old PHP example under my GitHub repo. So basically, go to my repo and search for whatever you're looking for. If you're looking for Java, I have Pet Clinic, which is a Java Spring Boot app, which I did earlier this year. And that one is using the Pet Clinic demo. And I basically make an advanced, what I would consider a relatively advanced Docker file. It's 50 lines, and it's using multi-stage. So there you go. That would be an example there. I can't found health check for PHP Apache Docker file. So a health check for a web app is simply just you would ping a URL with curl, or not curl, but with curl, which is fine. So you would curl an endpoint of your app inside the health check. So there's nothing really custom about that. You just need to pick a URL. Maybe it's the host page. Maybe it's a sub path or something, and then just have a curl in the health check, and then you would need to add curl to your container image, right? So that you have that inside there for running in the health check. But there's nothing really special about that. Yeah, I mean, essentially, it's health checking, just like it's running. All health checks in Docker are run in the container. So it's whatever you would do in the container to test that the application is valid, right? So you, as the application owner, how would you know if that application was really working? Do you write custom code that does a bunch of checking of things from inside that application, and then you make a custom URL that's maybe website/health check or something like that, or /healthz, as some people have standardized on. That's what you would do. But you're running it inside the container, so you would run it against localhost, not against like the domain name of your website. You would run it in the containers against localhost. So most examples will be something like, curl localhost /health, and they would have a special custom page that they built to do some basic checks to make sure the app has, is working, has all the things it needs, it can function. And if it returns a 200 or 300, then curl exits with a successful 0 code, which is the way that Docker validates. It's all about the exit code. If it gets a 400 error or 500 error when curl hits that endpoint, it will then return a different exit code, like exit code 1 or 127 or something like that, and Docker would consider that a failed health check. And so you don't really need anything fancy there. Curl can do it. Yeah, it sounds like drop support for Swarm. I don't know that Rancher ever had support for Swarm. If you're thinking of Rancher, the application, not Longhorn, Rancher itself, yeah, back in the 1.0 days. You're welcome for the great content. Hello, hello. Yeah, sure. Coffee refill. Thanks for taking my course, Fernando. Very cool. Hello, Andrew. First time on the show. But yeah, hopefully that answers some of your PHP and Java questions. The difference, if I could update my PHP repo, would be I would make it multi-stage. Right now, my PHP apps are pretty basic, and they basically create a mono image of everything all in one. So if you look at the Docker file, it actually creates, there's a base image, and then it uses that base image. So if I updated it, I would make it all into one image instead of it would be a multi-stage image. But in the old days, before we had multi-stage images, you would create an intermediate image that would have its own Docker file, and then you would create your main image. So your intermediate would have all your dependencies, and your main image would just have your application and the application dependencies. So if you looked here, you would see that there's two Docker files, and this one has Composer, Nginx, Node, right? It has all these different things in it that are the dependencies before you run any PHP app. And so it's basically just a bunch of, OS level stuff. It's using apt-get. And nowadays, all of this would be combined into one big image. It's a multi-stage image. And then the idea would be is that standard middle image that we called an intermediate image would be the one that all your developers would use to depend on. In this case, like right here, they would depend on that image for adding their application. That way, their application Docker file is much smaller, right? So it only installs the Composer dependencies for PHP. Then it copies in your source code, and it also does npm dependencies. If you're using Bower, Laravel, like it's got all that stuff in there. Because I find that a lot of PHP developers have all this stuff, right? They're using everything. They're using Composer, they're using npm, they're using Bower. They've got lots of this stuff, and their build pipeline is really long. So we broke it up. But nowadays, I would probably just turn it into a really long 200-line image. Also, if you're using Kubernetes, you probably wouldn't do it this way. You'd probably keep your PHP and your Nginx separate, and they'd be two containers in the same pod, because Kubernetes can do that. Docker can't do that. So this was for a company that was specifically doing Docker and Swarm, where they can't guarantee that both containers are running side by side. But you can do that in Kubernetes with pods. So with that, I wouldn't maybe make my own custom images, because you notice that we started in their base image on this PHP when we started from PHP FPM. So in their case, I would have the PHP FPM image, but I wouldn't install Nginx or any of that stuff. Nginx would be its own separate image running the standard Nginx image. So this definitely could use some PRs, and it looks like I have one. It might be somebody fixing a small issue. This is a year ago. Updating the PHP versions. So we could probably do some serious updating on that PHP. The team of bigwigs rejected Docker. So thanks, Marcos, for taking my course. Realize that eventually, unless they decide to go pure serverless functions as a service, or do something like Netlify, or basically where they're outsourcing that problem, they're eventually going to have to use containers anyway. Because I think the whole industry has settled on, if you're not using containers and you're not using serverless, you're not using Heroku, right, where you're basically outsourcing the building and maintaining of servers, eventually every company is going to have to go containers. So whether they're Docker or they're doing Kubernetes, or to me, serverless is just another abstraction on top of containers. You're outsourcing the problem of running the container with all the dependencies. You're outsourcing that to the serverless vendor, which is running the container for you. So it's unfortunate they said no, but that's just no for now. For a lot of teams, I don't focus on the technology when I'm trying to sell it. We focus on what are the business objectives or what are the business problems that you would like to address or that you even think you can address. Usually that's things like long build times, long CI test cycles, right? Really complicated and fragile server setups where you're custom building bespoke Linux servers and those servers can't just die and go away. So, teams that have automated all that out of the way, those tend to be the companies that are last to go to containers because they've automated so much of their infrastructure, but they still need a team to manage that infrastructure and all that automation. Where we've standardized as an industry on containers as the way to automate all that, that's you're sort of using a tool to solve that automation problem of building servers, making the applications reliable, whether you're on Mac, Windows, Linux. That's kind of what I focus on, not so much the, hey, Docker is cool. And I'm not saying you did this, but focusing on the tool itself is not so much what I try to focus on. I focus on let's have goals that are business objectives that are all about the bottom line. How fast can we ship code? How quickly can we restore servers? How can we speed up our deployment pipelines? Can we get our DevOps team to not have so many servers to manage? Like, can we reduce the burden on operations by removing a lot of the server infrastructure, right? If you're using something like EKS on Fargate, there's no more servers to manage. So those people, they don't get fired usually. They just go get other work. They already have so much else to do that they can now focus on other problems that they were not able to focus on, like maybe security or automation. So hopefully you can go back another time, maybe once they've had some more time to think about it and that they can, take containers. Otherwise, you know what? Containers might be your next job. You might get a different job that is using containers. Don't use official DigitalOcean storage driver. I didn't know that there was an official storage driver, but could we see Bret versus WSL show? So I'm assuming that means me setting up WSL. Yeah, we could do that. I could do like a from scratch. What does it take to get WSL set up? That's not a bad idea. Let's add that to the little list there. WSL setup. So if you're on Windows, this would be like a Windows only show. Right? Let me add that to the little list here I have on my screen. Is it multi-stage in your Udemy course? I'm just starting out. So multi-stage is not a part of the main section. Once you get to the advanced levels down at the bottom of the course, there will be a couple of videos on multi-stage, and a lot of my examples are multi-stage. So you will see as you're going to start watching things at the end that are a little longer, a little random. The original part of the course has not been updated to do multi-stage yet because multi-stage is one of those things you want to learn after you've learned a lot of the tooling because it's an advanced concept and it's essentially like making multiple Docker files in one. But a lot of my YouTube videos here talk about multi-stage. So if you just go to, Bret.live and search in there for multi-stage, you will find we talk about it on quite a few videos where we give demos and examples. I have people on the show that demo multi-stage. And then if you go to take my Docker for Node.js course, which in case you're interested at all in Node.js, it's not about learning Node.js. It's basically how do I apply Docker to a specific programming language. And quite frankly, I could have called it Docker for PHP or Docker for Java and then maybe changed 10% of the course and it would have been the same course. But in that course, there are videos specifically on multi-stage that show exactly how to build a multi-stage app for Node. But great question. Red Hat only recommends Ceph. Even Gluster is also a Red Hat. Yeah, Red Hat has taken over that Gluster project. All right. So I'm caught up to all the Q&A questions. So in case you're just joining, we were working on this list of Swarm solutions, essentially, for adding examples. And I probably should add those. Where'd I go? Where's my dog versus cat? So in my dog versus cat repo, I've already got all these Swarm examples. And right now, they're using DigitalOcean. And I could probably, because to me, there's two use cases, for two main use cases for storage. We all have our own storage requirements, but the things that I get the most are, the first one is I need to store static content like blog uploads, like Ghost, WordPress. I'm going to have user uploaded content, and I'm going to have a multi-node orchestrator, whether that's Swarm, Kubernetes, or whatever. And I need that those uploads are available on whichever node that the WordPress or Ghost or Drupal spins up on, right? I need my themes. I need whatever other static files are in the content directory. I need those on node 1 or on node 2, depending on where the container starts up. A more advanced version of that is that I need to run that website on many different containers for redundancy, and they all need to be able to access the same storage. So they need shared storage support. All right. That requires that you have some sort of either automatic replication or some external EFS type of NFS solution that allows multi-read write. So those are the two most common. Whenever someone talks to me about databases, I tend to wave off the customized orchestrated storage solution, and I say, like, you're out of the gate, you're brand new to this stuff, keep it simple, and if you're going to run databases and you're going to run them in containers, run them on dedicated nodes, pin them to those nodes using constraints, basically those labels that constrain to only having that container run on certain nodes. And in Swarm, if I was doing, let's say, a 2-node database cluster or a 3-node MongoDB cluster, I would create 2 or 3 services. I wouldn't make them replicas in the same service. The replicas in a service for Swarm are designed to be identical. They're designed to be things where they are always the same. And a database replica is definitely not the same as its master. It's usually got a different configuration. It's certainly got different data files. And so it's technically a different entity. It has a different name. And so I tend to put those in separate services with a database. And to me, that is after I've already ruled out any cloud hosting of databases, because again, I don't want to run the databases myself. I'd rather someone else do them who can do them better. And almost all companies that come to me for consulting, I'd say 98% of them are running cloud storage. Or if they're in a data center, they're running some third-party storage solution like NetApp. Anyway, so it's rare for me to ever have to work on a custom storage solution for a consulting client. Pretty rare. All right. Any other things here? How to decide which one to use, Swarm or Kubernetes? Honestly, nowadays, most people's decisions are made for them. It's all about your application requirements. Does your application require Kubernetes? A lot of applications nowadays do. Does your company mandate that you use Kubernetes? A lot of companies do. They mandate Kubernetes. If you're just using personal projects and you want something easy, totally do Swarm until you can't. Swarm is going to require less of your time. It's less resource intensive. It doesn't need as big as servers, unless you can do something like DigitalOcean's Kubernetes or Linode's Kubernetes or anyone else's Kubernetes, but you're still going to have double or triple the number of YAML files lines just to do the same thing in Kubernetes that you do in Swarm. So if I'm working on small teams, small projects, I will recommend Swarm if they don't have a preference, just to get them started. Here's the reality of what containers are going to do for you. They're supposed to allow you to be agile, which means the decision you make today on orchestration doesn't have to be forever. If you start with Swarm, which is essentially compose files and Docker servers, which you should know how to do those things, right? You should know how to do compose files and Docker servers. A Swarm should be easy to set up and easy to tear down and easy to add nodes. It's a one-line command to add a node to Swarm. So you're not investing a ton of time in cluster setup, right? You're going to use Portainer as the GUI for Swarm, right? Portainer, that's the best GUI manager on top of Swarm. You can find plenty of things like Swarm Prom, which is if you want to do your own metrics, which I'm not saying you should, but if you want to run your own metric server and monitoring server, you can use Prometheus, and there's a Swarm repo for that that's being maintained that allows you to get all the nice, pretty metrics. I don't know if he has a screenshot here. It's too bad. Yeah, so a screenshot of all the metrics you could want out of a Docker server running Swarm. So, you could do that in Swarm relatively easy. And then later, if you want to mature to Kubernetes, first you've got to learn it and you've got to build it, or I prefer to run a cloud-hosted version. And then you might end up using Prometheus, which you already have learned. You might decide to, use Portainer, which supports Kubernetes. So you're not having to restart. You're still using the same Docker files. The YAML stuff you learned, you will be writing new YAML, but you still had to learn YAML if you aren't already using YAML. So, I don't look at these tools as one or the other. I look at it as maybe I start with Swarm on small pet projects, and then as I mature, I grow into Kubernetes and using Kubernetes out of the box. Let's see. Which is the best PV solution in Kubernetes? I can't answer that because I don't know if you missed the beginning of the conversation, but at the beginning of the show, I talked about that with storage, the last thing you're going to decide on is the Kubernetes CSI, the driver. It's all about, first, what are your application requirements? Do they need shared read-write storage? Do they need read-only storage on many servers, or is it just single container, single read-write solution, which is the simplest? Does it require off-server storage, or can it be on-server storage? Is it in the cloud, using the cloud vendor storage? Is it your own dedicated storage in your data center? All those decisions have nothing to do with Kubernetes. So once you've decided on the options for that, then you will look at what is the preferred driver for that solution. And most of those solutions only have one driver, one CSI, or one built-in one, right? So that is what you're going to need to decide. And a lot of teams, if they're super advanced, will have multiple CSIs. One that's maybe using EFS, one that's maybe using replication. But most of the teams I work with that are serious, they outsource everything. They are using RDS on AWS. They're using other people's databases, and they're avoiding persistent storage as much as they can altogether. They're not trying to be their own storage team where they have dedicated storage experts, which is what I used to have to do. I had a team of people in their own office dedicated to managing data center storage, and it's a full-time job. And it's a very important job. They have to constantly monitor backups and test recovery, all those things that you don't have to do if you outsource your persistent storage requirements. So I guess really the long answer to that is it depends. Other tools like Dive to see what's inside the Docker image, layers, files, etc. The Dive is the only one I know of that does that. Other than exporting, I mean, you can always export, right? You can export an image out to the, you can run a container and then export it out, right? And so you can pull that stuff out to the file system and then look at it yourself with any Linux tool, right? DF, Tree, all these Linux tools out there. But dive specifically does that inside the container. So it's basically extracting those layers in the image and looking at them. Right? So if anyone hasn't seen dive, dive is a command line tool that allows you to study images. I'll put that into chat. But I don't know of another container-specific tool that is like dive in that it gives me a GUI in the command line to look at my local images. And you can see up at the top left, each one of those lines is a layer. And then on the right is my file system. So I can shrink. I can collapse directories, stuff like that. So I can move through the file system, and the directories that are colored are the ones that changed in this layer of my image. So if I'm really studying an application, so maybe someone came to me with their own Docker file that they wanted me to research and give them advice, because I do that. I give them advice on how to make their Docker files leaner and more secure or safer or whatever. I'll sort of do that audit. And this is one of the tools I would use because it allows me to visually study, and I can say, okay, in this 81 meg, right? Because up here on the left side, 81 megs is the size of this layer in the image, and then on the right, I can dive in and see which files it added. And so often when I'm doing multi-stage images, I will break this stuff up in the multi-stages so that the stuff that doesn't need to be there for production isn't there. For example, build tools don't need to be in the production final layer. So with multi-stage, you can separate all that out and it won't be in the final image. Basically, the tools are added and then they're sort of thrown away with an image that's disposable during build time. And that's what multi-stage does for you. Anyway, so that's what I do with Dive, but I don't know of another tool like that. That's pretty cool. So next question. What is the difference between CNI plugins for Flannel, WeaveNet, Calico, and kubeproxy? So most of those tools will work with kubeproxy. Kubeproxy is usually required, but not always. Those tools all have their own feature set. And some of them use overlay networking. Some of them support network policies. Some do neither of those. There is, if you go into my Kubernetes mastery course, so let's see, course.kube. Oh, I'm not logged in. All right, let me get into the course real quick. So in my Docker mastery course, let me see if I can find where I put it. There's a link. There's a resource link that gives you a spreadsheet for comparing CNIs. And I'm not sure where I put that. Now, out of the box, Kubernetes has something. All right. I found it. So this was in Kubernetes Mastery. Under the networking model stuff. No, this must be this one. So I'll put this one in chat. Networking plugins, but there's a spreadsheet somewhere that I gotta see if I can find. But that exactly, yeah, that's not, maybe it's not on there. Maybe it's on the kubedex. This is a little dated. Here we go. This is probably a little dated. I'm not sure when it was last updated. You can look at the, but it basically there's three main areas that you want to look for. One of them is it using overlay or is it using raw networking? Overlay is what Docker Swarm uses. It's an encapsulation of the packets. It makes it for ease of use, and it allows you to go across things like NAT. It basically solves some problems, but it adds a layer of latency. So it can cause sometimes up to 10 to 20 milliseconds of latency in your networking if you're not careful. Because it's using the built-in kernel functionality to do overlay networking. WeaveNets does that out of the box. I know other ones support it. Docker Swarms does it automatically with its overlay networking driver, which is the default. And it's great for a lot with web database stuff, like web front end, database back end. It's perfectly fine. I don't have an issue with it. When you get to larger networks and larger, more complex setups, and you really are dealing with things that are very network sensitive, so that maybe even 10 milliseconds of additional latency is a problem, you might want to look at something that's not using overlay. Typically with Kubernetes, the default out of the box with just one node doesn't use overlay, but once you get to multi-node, you have to worry about an overlay. You have to worry about whether you're using Calico or Cilium or whatever, Flannel, whatnot. I think Flannel also does VXLAN overlay. In fact, you can actually see here default networking model. See this right here? Excuse me. That is the type of so the layer 2 VXLAN is all about the overlay, which again has advantages, but performance is an issue. A lot of people worry too much about performance when they're first starting out. They think it's going to be a huge issue, and it quite often isn't if you have at least gigabit on your networks. So funny thing is people tend to get a lot of small AWS instances instead of just a few really big ones. And AWS instances are notorious for having horrible networking. So you always want to go to something like EC2 Info. And before you pick the size of your cluster, always look at networking performance, right? And you don't want this stuff that's like low to moderate and moderate, right? You really don't want that stuff. You don't want those cheap instances that don't have high or better gigabit. High would be, I think, gigabit. Up to 5 gigabit is beyond that, and then up to 10 gigabit beyond that. I always prefer getting a fewer number of bigger nodes that have more CPUs, more memory, but also, more importantly, with an orchestrator, higher networking. So I never recommend a business, deploying on low to moderate or moderate instances, because that's going to have crappy networking, and it's going to suck no matter what you do. In terms of your applications going to your databases, it's going to add latency over time as you start to bundle things up. Because now think about it. You're doing containers, you're doing orchestration. That means you've got a bunch of different processes all running on the same node now, and they're all trying to use that same networking pipe. And if that pipe isn't at least gigabit, you're probably going to run into some sort of headaches. Swarm will actually do this where people will notice that over time, as they put a lot of stuff on their Swarm, that their Swarm manager, the current active manager, starts to flip-flop. That's almost always a networking problem, because if there's enough latency because of too much networking stuff, the nodes can't talk to each other to make sure they're alive. And so they will start to flip-flop because basically they're saturated networking and they think they're dead. That's a troubleshooting technique on Swarm. So yeah. Let's see. Is the same tool for containers or just for images? That only does images. Great question. So we're talking about on Dive. Dive, all you have to do to test it on a container is to just save that container to an image. So do a Docker commit, and that will take the container and turn it into an image. And then you can do Dive on the container, right? Because that container layer is one layer on the final layer on top. And there's no, I don't know of a tool that will tell you for a specific container how much storage that's taken up. Although maybe Docker, who knows? Maybe Docker has added that. I don't think I have anything. I think I cleaned up before the show. Yeah, I don't have any containers in there. But I don't think there's a metric there that it shows it per container. Although it does say sizes, so let's do something. Let's just do a Docker run. Let's just do that. And then if I then do ls, so there you go. So it's kind of hard to see this, but answering that question, if you can see all the way over on the right, even though that's cut off, let me zoom in. Try that again. If you look over on the right, well, now it's wrapped, so it's down here at the bottom, but it's basically saying the container layer on top, which there's only one layer for the container, that's the read-write layer, and it's using 1K, and virtual means this is the image, this is all of the image, and then this is the container on top of it, the container layer. And since it's just Nginx, it's not doing anything. But if I did that for, yeah, I don't have Redis. Maybe would do this. See if it'll pull up more storage. It's saying on Redis 0. Oh, because it's not storing it on disk. Okay, so you have to do a Redis startup option before it'll write it to disk. Otherwise, it's all in memory. But yeah, I would expect Redis to actually have a little bit larger, or a MySQL database, something like that. So you can use that -s. So you technically don't need to use commit, I guess is my point. But if you wanted to see that all in the Dive interface, you just commit the image to an image. Do you have any example of CI/CD with Swarm for GitLab or GitHub Actions? So, okay. Docker, Swarm. The answer is technically no, I don't. I don't have a CI/CD example because it's just a command. The way that command would work is Docker, Swarm, most people want to use stacks, which are YAML files. So your decision is, when do I decide to automatically deploy? Because that's, if you're asking for a CD, then you're talking about automatic deployments. So are you automatically deploying on every image commit to a certain branch? Or, a certain tag? Are you, what is that dependency? Do you have to update the YAML and change the version tag, basically for your images of your apps in the YAML before it will automatically kick off? So you first have to think of step one. What is the point at which it's automatically deploying? And then you got to put that in as some sort of CI/CD solution, right? I mean, you got to put that in there. That's not anything to do with Docker. It's probably going to, go off of a Git commit. For some teams, I like when their CI/CD solution gives a tag to the image after it successfully builds it and tests it, assuming it's got all the tests. If they're ready to automatically deploy it, then it will update with a new tag in the Docker the registry. So right, it's pushing it to the registry, and it's giving it a tag that is basically it's the Git commit of the source code. So that way you can easily reference back to which commit ID is where that image is coming from. You never want to reuse those tags. Never reuse the latest over and over in automation. You always want to make a new one. So now your Git solution has that commit ID, so it knows which tag to deploy. and it's going to use a stack file, right? And that stack file is going to have an environment variable in it for the tag ID for that image. And it's going to have that environment variable, and you would just do a Docker stack deploy of that YAML file, which it would be pulling from some DevOps repo somewhere. And it would then substitute that tag inside of the YAML file, right? So since the environment variable is looking for an environment variable, and it probably is something like get ID or get hash, that's probably the environment variable that your CI solution already has set up. And that's the tag name of your image. And then that's going to be when you do a stack deploy. Now, how do you get to your server from your CI/CD solution? Well, with Docker, you want to do that with SSH. That's the easiest way to do it. So you probably, in a lot of cases, if you're doing any automation with CD, you probably already have SSH keys in your solution to get to your servers. And so you're going to simply do a Docker stack deploy command through the Docker SSH, right? So, in CI, that might look something like Docker host, right? Docker stack deploy some file YAML, and then the name of the stack. So my app stack. So that's going to be the command that your CI solution is going to run from inside of your CI, basically your CD DevOps repo. That, by the way, is not GitOps. That is not full GitOps, but that is automating infrastructure as code. And there you go. So you would have that SSH key. It would automatically SSH to the server running the Docker command. So Docker needs to be installed inside your CI solution. And this kind of setup works for GitLab or GitHub Actions, but I don't have I don't have a plug and play solution for you. But if you just look up Docker GitHub Action, they have an official one. So you can just use that action, and then you would have an SSH key that you would pipe in, right? It would be part of your secrets in GitHub, and it would use that as well as the commit ID. So you could set all that up, and then we'd do a Docker stack deploy. You can't technically use something like Portainer or the Docker API to do this. You still have to use the Docker command line, and the reason is that Swarm doesn't have an API for stacks. So you have to use the Docker command line for stacks. The API, which is what Portainer uses, only works with services. And so you wouldn't be able to take advantage of compose files with Portainer if you wanted to use Portainer's automation. Portainer itself has this thing where it will create webhooks. But I feel like nowadays, now that we have GitHub Actions, I'd rather just use SSH with GitHub Actions. So maybe we'll do that. Maybe we'll do that next time. Am I going to add that to my list? We'll do a GitHub action for a swarm. Let me see. Where's my to-do list? Let's add one more to the list. GitHub action swarm CI CD. That's another idea. All right, let's see what other questions we have. DNS RR is only for Swarm production, right? So test if you're still hanging around, which I think you are. So DNS round robin is for any situation where in Swarm, you only have one replica. You can do this, by the way, in Kubernetes. It's just a slightly different setup, but here's my attitude. Especially for databases. So a lot of times with databases, even if you have a replica, they're two individual services and they have their own DNS name. You don't ideally want a virtual IP and load balancer in between your apps and a single thing in the back. Like let's say you have a single MySQL database. You don't normally want to have another IP that's terminating connection and then retransmitting that packet to backend, because you have basically all this stuff that could go wrong. Packet sizes, you have packet open connections, right? So like open connections on databases is a thing, reusing open connections. And then you have things even with HTTP around persistent long polling, stuff like that. So anytime you put a virtual IP in the middle for the sake of load balancing and redundancy, you need it. You need it for that load balancing and redundancy. But if that back-end system is only one replica or one container running, then it doesn't add any value. So the way you do that in Swarm is you set, I think it's like a type, or let me just look it up. Docker Compose. This is kind of a Docker Compose tip. This is really just like production compose in any, and this is the same thing with Kubernetes as well. If you can avoid a load balancer between the stuff on your internals of the cluster, then do it. So yeah, endpoint mode right here. It's a little small, a little hard to read, but the endpoint mode defaults to VIP, virtual IP address. But if you only have one, if the service only has one replica, then the virtual IP isn't going to help unless you're doing rolling updates where you have to make sure that there's always one available and you're having to hop between the two. You know, if you're not really doing that because you have like a single MySQL database, or you have a MySQL or a Postgres replica and you have each container is one service, then they're not sharing the virtual IP. They're two different services. So the way you get rid of that virtual IP and have direct connection is by setting endpoint mode to DNS-RR. It basically means that it's only going to use DNS, not a virtual IP address, which means the connection is directly from container to container. This is more networking, and this gets into more of the networking stack of Linux than it does really Docker or Kubernetes. And that's why it always helped me to have a thorough understanding of networking. I took, early in my career, I took Cisco test. I read TCP IP books all the way cover to cover. Like, I really learned networking so that I would understand how these connections work, the overhead of TCP connections and headers, packet sizes, all that kind of stuff, right? So yeah, that's why I have DNS-RR in some of my examples for databases. You can run GitLab Runner on your server and it will be listening to your repo instead of SSH. Right, but then the GitLab, so the GitLab runner is now running inside your cluster, and it will still need to do a stack deploy instead of talking to the Docker API directly. So you can, that's a sort of a pull versus push methodology, right? And that's certainly fine too. I have not seen that setup where any of my clients would rather run GitLab runners inside their cluster. Most people that I know, all the companies I've ever worked with, they don't want to run their CI runners inside of their production clusters. They want that to be isolated on a separate, CI/CD build cluster. So if you're going, I'm sure that Dave, you already worked this out, but like if you're going to run a GitLab runner in your production clusters, you have to make sure that they don't inadvertently run jobs, right? They're not running builds inside your production cluster usually, because you don't want those resources taken up and consumed that you need dedicated to your production infrastructure. But yeah, that's definitely, I guess you technically could do that with GitHub, right? Because GitHub also now has a runner where you could do some of that stuff. But I haven't tried doing any of that where I run it inside the cluster just for the simple act of CD deployments. But yeah, I would love to see an example of that on how someone's solving all those problems and how that's necessarily better than SSH. Because to me, SSH is cleaner, just because I don't have to have an agent constantly running on my hosts, right? But the problem with the SSH is if you're pointing to a specific server, then that server could be a failure. Like if that server gets replaced and that IP gets replaced, then your SSHing for the CD could be a problem. So the way you solve that sort of link is you either put a load balancer for SSH, which you can totally do load balancers for SSH so that multiple nodes are behind that, or use elastic IP addresses for the nodes that are your management nodes, right? So in Swarm, you can only run a Docker Stack deploy on a manager node. So presumably, let's say you have 3 managers, you can have a load balancer that can use any of the 3 nodes. It doesn't matter which ones. And then that load balancer is sitting in front of an elastic or a auto-scaling group rather, and that auto-scaling group will then replace each of the manager nodes if they fail, and then you could always have the persistent IP address and for the SSH. So that's kind of how I see it done in AWS, is those two things combined. Does a firewall will conflict with Docker Swarm exposed? So it depends on the firewall. Yes. Yes, it can. So a firewall, let's see. Let's move down the green screen. So a firewall can get in the way. I have a list of firewall ports you want to keep open. I'll just post that. So you got to make sure that the firewall is not in the way between the nodes. And then for everything you're going to publish to the internet, of course, those ports have to be exposed in the firewalls. If they're external. Now, if you're talking about the node itself, Docker manages the firewall through IP tables. So if you're using an IP tables based firewall, then Docker will usually override that. But your mileage may vary. You will have to test with whichever firewall you're electing to use on the host to make sure that the Docker IP tables filters are properly working in addition to that firewall. Because if you've got a firewall and Docker managing IP tables, you could potentially have conflicts. So it kind of depends there. Yeah, one of the advantages of pulling, like your GitLab runner, is that your nodes don't have to be exposed to the internet on SSH. Certainly, if I'm doing that on managers, it's always going to be on a random high port that I pick. It's not truly random, but it's a high port that's going to be hard to find. And I might even block that down to only specific IP subnets. So if they're running from my GitLab runners or from GitHub or whatever, I will know which IP subnets I can depend on so that it's not completely open to the full internet. Like there's a lot of ways you can lock that down, but yeah. And of course, only SSH key authentication, never password authentication on SSH. In fact, I don't even think Docker works with password-based authentication anyway. But yeah, there's advantages, especially from the pull method of the GitLab runners for sure. So great idea. Thanks for bringing that up. All right, so on today's list, we talked about swarm volumes, but we still need to come up with this thing, which we're going to need to work on some of these examples. So I might put out a tweet or something about this and basically ask for people to validate a configuration and maybe even deliver examples. So maybe the community, you included, could help validate some real-world swarm setups. And then the next thing is on the list, dev tips. We talked about a couple of composed dev tips there, but I would say looking into all of my GitHub examples. So I have those on Node.js, I have them on PHP, and I have them on Java. So you can go look at my GitHub and just search for your programming language and see if I have a good compose example. And then on the PHP and Java, that was included. WSL setup and GitHub Actions Swarm setup are two options for the next couple of weeks. So look forward to me on Patreon. If you check me out on patreon.com, right? Patreon.com/Bret Fisher. You can follow me there, and you don't even, if you don't want to become a member, you can always just click the follow button and you can get all of my updates. But if you'd like to support this live show, which is supported by my sponsors and members here on Patreon, so thank you so much to those of you. You know who you are. Thank you for being supporters. And we get a couple new ones every week, so I appreciate all that you do for us and your continued gratitude to my show and the podcast that comes from this show, all the open source I do, all that stuff. So you can come here, you can join, you can get extra benefits. We're going to be doing our live monthly hangout. So if you want to join our monthly hangout where we all just sit in Zoom and talk about DevOps together, you can certainly do that on the $5 High Fivers Club. And then you will get updates here on what I'm going to do on the show. So if I'm going to do a Swarm demo or any sort of WSL setup, I will certainly let you know here on Patreon. And you'll be seeing some more updates on the Udemy courses coming soon to Kubernetes. The Kubernetes section on storage is what I'm working on now, so you will see that as well. And thanks so much for coming and joining. And I will see you next time here, YouTube Live next week, this time on Thursday. And also on, all the other things, Twitch included, Twitch, and what's the other one I'm on here right now? Periscope, in case you're watching me on Periscope. Ciao, everybody. Have a good week.